Hi everyone, in this video I will be showing you how to create an MCP server for your PyTorch model, and towards the end of this video I will be sharing a Jupyter notebook where we'll be creating an MCP server and also a client to take advantage of that server. And by the way, it doesn't necessarily have to be a PyTorch model, it could be any large language model. For example, in the tutorial I will be using Qwen from Hugging Face. My name is Abdul Salam and I'm a PyTorch ambassador. MCP stands for Model Context Protocol. Now, we all know that large language models, the more context you give them, the better. And sometimes they need access to tools and even resources. In this case, when we say tools, it could be a function, a Python function, for example, that access information from a database and then gets the results, append the results to the original query for better answers. And so MCP standardizes how large language models access tools, use the tools, and external context, essentially more information here when we say external context. So this is also very important for agentic workflows. Let's look at an example. Let's say in your system, you might have an agent that needs access to GitHub, maybe to read information from a particular repository. So GitHub could provide an MCP server and your agent could act as a client to get information from the repository, for example. And you might have an agent that wants information from your file system, maybe from a folder to get number of files or maybe the size of a particular file. So in here, you might need to create an MCP server and your agent could take advantage of that. Let's look at one more example. Let's say you have 3 applications. All of them, they need access to GitHub. Maybe the first application could be a cursor like coding assistant. It could be the second application could be a Slack AI bot, for example. And the third assistant could be a personal research assistant. And all of these 3, they need to read issues from GitHub. They need to search repositories, for example, or also open pull requests and also check some logs, for example. Now, without MCP, this could be a solution. For the coding assistant, you might need a particular connector, maybe an API, specific for the coding assistant to access information from GitHub. And the Slack AI bot might need a separate connector, different implementation for integration with GitHub. And the personal research assistant might need a custom integration with GitHub. So here on the left, we see that each application needs its own connector, maybe different authentication handling, right? And different API logic. So, and also the API can change and there might need to be an update to that. Here you can see that there's a lot of repetition. With MCP, it really becomes much more easier. So all of the 3 applications, the coding assistant, the AI bot, and the personal research assistant, they act as MCP clients, and the MCP client is going to be communicating with GitHub MCP server, and the GitHub MCP server provides information such as tools, more resources for the agent, which are large language models, and they are intelligent enough to select tools specific for a particular request. And you might be wondering, what is the difference between MCP and APIs? So on the right here, we have a simple API. The API takes in a repo, for example, the URL, and it sends a post request, and then it returns something here as JSON. If it is an API, you need to know the URL, for example, and you need to do some authentication handling, and you'll be responsible for writing the functions to access information from GitHub, for example. So you are essentially writing the connector yourself. But with MCP, the server already exposes information such as create issues and read issue, for example, as tools. So let's look at the architecture. On the left, we have an MCP server. On the right, we have a client. The MCP server provides tools. The client uses them. Provides resources. The MCP client uses them. This is really a simplified architecture, and it also provides prompt templates. These are maybe like tested prompts for a particular request that the client could use. So let's see what the server can expose. So for example, we might have a simple Python function. To expose it as a tool, all you have to do is decorate it with mcp.tool, so it becomes a tool. And by the way, we will be using this fast MCP library. And it might appear very simple, but really this function could be accessing information from a database, and it could be a very complex function. And in here, for example, the server could be exposing resources. So this is just a dictionary, and then it exposes it as a resource. So all you have to do is wrap that information with mcp.resource with this URI, for example. Here also it might look very simple. Here we are using a dictionary, but it could be a database. And one more thing here, a prompt template. This might be from the server, a well-tested prompt that the clients could take advantage on. So all the client has to do is insert arguments into the prompt template, essentially for better answers. To convert a template, a prompt template, for example, the way we do it in fast MCP is to decorate a function with mcp.prompt. Now let's go a little bit lower about the architecture, about transportation. There has to be a handshake between a client and a server. So let's talk about transportation. The transportation is essentially the communication channel between the MCP client and the server, just as I have said. In our case, our server that will be building runs locally. We are going to be using standard IO. So the client starts the server, it sends requests and reads responses through standard input and output. But for remote servers, MCP uses HTTP based transportation. So the transport essentially moves the messages and the tools do the work. And by the way, standard input is the channel a program reads from, and standard output is the channel a program writes back to. So transport, I have mentioned this, how MCP messages move between client and server. For our case, we are not going to be using HTTP. Everything is local, so we will be using standard IO. For remote MCP servers, we use streamable HTTP. So in here, what we'll be doing is the notebook will act as the client, right? And through standard IO, we are going to be creating a server, which is going to be a Python file. All right, thank you very much. Let's go to the implementation. Okay, so we are in the Jupyter notebook. What we are going to be doing is we will be creating two tools. Number is going to be a tool to search learning notes from a dictionary, but in reality, instead of that dictionary, you will be using a database, for example. And then we are going to be creating a tool that takes in a PyTorch module and also arguments and runs that module and gives us the response back. So we are going to be using Qwen. I got it from Hugging Face and Python 3.11. All right, so let's get started. So what's going to happen is the user is going to ask a question, and Qwen, our model is the large language model itself, is going to decide if a tool is needed. If it is needed, Python is going to execute that tool, and the tool result is going to be appended to the query, and then the model is going to give us, I believe, better answers because of more context. So I'm going to start by importing the libraries that we need. So in here, I have this learning notes, which is a dictionary. It contains information about MCP, which we are doing. It contains information about PyTorch. Okay, this is a dictionary, but as I've mentioned, in reality, in production, this is maybe a very large database. So I have this function that takes in a topic and searches the learning notes. So let's see how it works. So it takes, let's say, MCP. It searches this dictionary, all of these dictionaries, and returns the specific dictionary that is related to MCP, for example. I also have this function that runs PyTorch modules. So let's see how it works. ReLU and the arguments. Okay, so we got this. I've printed the results. In the server, we are going to be taking these two tools, search learning notes and run PyTorch module, and we're going to be decorating them with mcp.tool to convert them to tools in the FastMCP library. Now we need this also. I created a dictionary. The key is the function name and the value is the function itself. It takes the tool name and then the arguments for that tool and then runs it. So for example, in here, it takes this tool name and the argument, runs it. So here what I'm doing is essentially building the utility functions that we need for our implementations. Let's continue. I'm loading the large language model. We're not going to go into that. You can download that from Hugging Face. Now this is very important. I created this tool router prompt. It's essentially a prompt that looks at your input query and decide the tool that is necessary for that particular query. And if a tool is not needed, it's going to not use a tool. And the large language model is going to be responsible for taking in this prompt and deciding if the tool is needed. I also created this extract JSON. We're going to see what that is. And then this is where the model decides which tool to use, even when it is needed. For example, here, what is MCP? Let's see the results. Okay, so we got this. This is the model's decision. It tells you to use a tool, it tells you the tool name and also the argument for that tool. And what I did is I implemented this extract JSON, which essentially takes in the output from the large language model and then format it well that we can actually use for the fast MCP library. Okay, so we need a more like a standard JSON for all of the outputs. So that's why I created this extract JSON. As I have mentioned, we are going to be taking in those functions and decorating them with mcp.tool to convert them as tools for the server. And that is exactly what I did. I'm going to go into this learning hub server. So I copied all of those functions. We already saw that I decorated it with this mcp.tool to tell fast MCP that this is a tool. I also created a resource. For resource, you decorated with mcp.resource and give it a URI. I also created a prompt that the server provides. So this is our server that the client, which is going to be our Jupyter notebook, is going to be communicating with. Let's go back to Jupyter notebook. Now we are going to be going a little bit lower level here, but this is really not complex. From MCP, we are going to be importing some utilities, some functions, for example, standard IO server parameters. This is essentially used in telling the MCP how to run the server itself. So in here, I created an asynchronous function. It is asynchronous because it has a wait. So typically asynchronous functions are used when inside the functions there is a communication to a particular external system and that communication might not be instant. So in our case, we'll be connecting with a server and we don't know when to get the response back, so we wait. And in those occasions, we typically use an async function. Okay, so that's why we have async, then the function. So we imported this, we told it how to run the server, which is Python learning hub server.py. So when you go to terminal, this is what you typically do Python, then run this. So in here, what we do is we open read and write streams. So for example, the read is how the client receive response from the server and the write is how the client sends information to the server. And we are going to be using those streams to be creating a session. We are going to be initializing it. So this is a little bit lower level, by the way. Then after then use that session to get information about the tools, the resources, and the prompt that the server provides. In here, I'm just printing them. Okay, so after running it, these are the results. Now I created another async function specifically for calling a tool from the server. So this is what we did. Opening read and write streams, initializing a session and calling a tool. So this function takes in the tool name, the argument, right? And then it returns the results.content. Let's run it and test it. And it returns this. And okay, it's a bit messy, so we need a utility function such as this to convert the MCP content to text, something nice. So that's why I created this function. Now I'm going to create the final chat where we'll be interacting with the large language model, but in an intelligent way where tools are used. So when the query comes in, first we decide if a tool is needed. If it is not needed, for example, in this case, the model answers directly. And if it is needed, we get the tool name and the arguments. After doing that, we call the tool, we get the result from the tool, and then format it well and send the two results to the large language model for better answers. So I'm going to run it. Okay, so what is MCP? It decides, okay, a tool is needed, and this is the tool name, these are the arguments, and this is the MCP tool result. So the tool got executed, and this is what it returned. And then this is the model's response using the tool's results. And let's try one more. In here, a tool is not needed, so it answers directly, how can I help you today? All right, so I hope I was able to help you with MCP server. Thank you very much. I will see you in the next video.